So this section is a review from advanced functions. You should have used polynomial long divisions to pull a factor out of a cubic, and you should have looked at composite functions to figure out when they were equal to 0. So I'm just going to go through it again to make sure we're all on the same page. I'm going to use the same three functions that we've been doing points of inflection on and max-mins, so that when we get to the end of this section and the topic of the domain error, that we can put all of these functions features together and actually craft a sketch of them. So the cubic that I was working with was m of x is 1/3 of x cubed minus 3/2 of x squared minus 18x plus 18. So unfortunately, the only way that you can start with this cubic is to guess and check values of x in here, 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 and here to try and force it to be 0. Because at an x-intercept, the function itself is worth nothing. You should think about that. If you're on the x-axis, the y value is 0. That's why there's a 0 here. So there are a few tricks you can use. Like you can use the number at the back, and you start guessing things that number divides evenly by. So I could try +1, subtract 1. I could try +2, subtract 2. +3, -3. 4 doesn't go, 5 doesn't go. +6, -6. ±9, ±18. That's a little big long list. So I'm going to just use my super highly attuned powers and pluck the number -6 right out of the air. Let's try x equals -6. And you should be rolling your eyes at this point. Obviously, I'm going to pick one that works because I'm the one who made the question. But you may have to try 1, 2, 3, 5, right? Like whatever, to try and get this thing to equal 0. And it may take you a few tries to find it. Just to confirm that that works, I'm going to pop it into the function there. So 1/3 of -6 cubed minus 3/2 of -6 squared minus 18 times -6 plus 18. What's that going to equal? Well, that will be 1/3 of 216 minus 3/2 of 36 plus 60 plus 108 plus 18. 1/3 of 216 is 72. Half of 36 would be 18. 18 times 3 would be 54. Plus 108 plus 18. And that's not going to work. It's because -6 cubed is -216. All right. So 70 and 50 is 120. 2 and 4 is 6. That's -126. 108 and 10 is 118. Plus 8 is 126. So that does, in fact, equal 0. So because m at -6 equals 0, x plus 6 must be a factor. All right. So I'm going to divide this out using polynomial long division. I'm going to erase this just so I have some space. So I need to get a 1/3 x cubed from an x. That's going to need a 1/3 x squared. So that would be 1/3 x cubed. 1/3 of 6 is 2 x squared. These are gone by design. -3/2 minus 4/2 would be -7/2 of an x squared. And then these things I haven't dealt with yet. So I'm going to need a negative 7/2 from this. That means I'll need a negative 7/2 x. Give me negative 7/2 x squared. A half of 6 is 3, and a 3 times 7 is a 21. That's negative 21x. Negative 18 subtract negative 21 gives me 3 x's. And then plus 3 goes here. 3 times x would be 3x plus 6. No, 3 times 3 is 18. Going in evenly, which is good because this thing was a factor, so it must come out equally. So what I've just figured out is that this big, long, obnoxious cube is the same as x plus 6 multiplied by this thing up here. 1/3 x squared minus 7/2 x plus 3. So I have this part as a quadratic, right? And this whole thing is supposed to be equal to 0. So I'm going to erase this. I'm going to set up my cases for when this thing is worth nothing. So case 1 is when this first bracket, x plus 6, is worth nothing, and case 2 is when this bracket, x plus 3, is worth nothing. Now this one I already knew, x is negative 6. I guessed and checked that one out of the blue at the beginning. This is a quadratic that I'm going to use the quadratic formula on, but before I do that, I'm going to get rid of some of these fractions because I don't like the idea of having to put them in quadratic formula. So I'm going to take this entire line and I'm going to multiply it by 6. Now I can do that as long as I multiply both sides of the equation. 6 times 1/3 would be 2x squared. 6 times this would be negative 21x's. 6 times this is 18. 6 times 0 is nothing. Now I don't need to put all those fractions in my quadratic equation. I can just say that x is negative the b value plus or minus the square root of the b value squared minus 4 times a times the c value all over twice the a value. That's 21 plus or minus the square root of 21 squared is 441, I think. Yep. 4 times 2 times 18 is 144. All over 2 times 2 is 4. 441, subtract 144 gives me 297 over 4. And this is not a clean square root, so I'm going to have to use my calculator to do this. Either x is 21 plus square root 297 over 4, or x is 21 subtract 297 over 4. So the square root of 297 is around 17.2 plus 21 divided by 4 gives me about 9.56. And 21 subtract the square root of 297 divided by 4 gives me 0.942. All right. So what I've just figured out here is that there are x-intercepts at negative 6, 0.942, and 9.56. So when I go to sketch this thing, it will cross the x-axis in those three places.